Hey everyone, today let's try to solve this problem called the length of the longest valid substring. This is a relatively hard problem in my opinion, and I will try my best to explain it. Basically, in this problem, you are given a word and an array of string, which is called forbidden. Basically, we want to return the longest valid substring inside the given string word such that that substring does not contain any of the string in the forbidden. So let's take a look at the first example. We are given the word equals to this CB AAAAABC, and forbidden is a string array which is AAA and CB. Now we can iterate every possible substring in Word, and then we can see, for instance, this is a substring which is of length 5, but this length 5 substring have this AAA here, which is forbidden because AAA is inside the forbidden substring. That's why this CBAAA is not good. Actually, if we look at every possible substring inside Word, the longest substring we can find that is not violating the restriction from the forbidden is this AABC. So that's why we don't have to return the AABC, but we have to return the length of the AABC. So let's take a look at the second example. This time we are given the word equals LeetCode, and the forbidden array is DE, LE, and E. Again, there are a bunch of substrings that are valid, but we can see this TCOD is the longest that does not violate any restriction from the forbidden. For example, if I choose a one that has 5, for example, this TCODE, it is not a valid substring, even though length 5 is greater than length 4, because it contains this substring here, DE, and DE is inside this forbidden substring. That's why we cannot choose this DCODE. Right, so that's pretty much all for the problem description. And let's see how can we actually solve this problem. So there are mainly two idea/observation you can make to help you solve the problem. The first observation is that the length of the forbidden word will be at most 10. And the second, when you see something like substring or valid substring, this kind of stuff, it is usually kind of related to a data structure called trial. Because trial is usually used in a substring problem, and even more so in the substring hard problems. So that's the two key observations or key ideas that can help you solve this problem. So let's see that we decided to use a trial. What should we put inside the trial? Well, what if we put the word in it? it doesn't make sense to put a word in it, right? Because the word, there's no branch for it. There's only one string. Instead, how about we put the string in the forbidden? For example, this AAA will become something like this. And then, so this is the root. Okay, it's actually quite hard to draw. Okay, but you can see it. So this is C, and it is B. So assume that we have this trial, and combine with the fact that the forbidden word length is so small that it's 10. We can just iterate every possible start of the word, and then we can go 10 steps forward, because at most the forbidden word length will be 10. For example, if we start here and we go 10 steps, and we can see if it can reach any forbidden word. So what does it mean? For example, when I go to here and I reach 1 step, 2 step, and at this point I'm reaching the end word of a trial, which tell us that this is actually a word in the forbidden. Now, what do we want from this index? It tells us that if we reach this index, we should move our left pointer to as soon as the start of this forbidden word +1. So if we end here, and we know for sure that it is failing because this is one of the end word from the trial, and there could be multiple possible start from the trial, but we just picked the rightmost one +1. So this A that I'm highlighting is the earliest start that we can make if we want to include R. In this way, we can consider this. So let's move to the next A. So if we want to include this A, the earliest L that failing is this one. So the rightmost, the earliest that we can pick for the L is this index. Because if we pick this index, this will fail. Because now we include this AAA, which is not good because AAA is inside is forbidden. And if we pick anything before this index, it will fail because of this AAA. So that's why I said this A is the earliest thing that we can pick for the left pointer if we want to include this A highlighted as the right pointer. I hope that makes sense. Let's jump into code implementation. Okay, again, I'm going to use Python to solve this problem. But it should be pretty similar for all programming language, for the idea at least. First, I'm going to create a trial node class, which is a pretty standard thing. Each trial node will have an is end, and when it is false, it means that this trial node is not actually the end of a forbidden word. And if it is true, it means that we have hidden a forbidden word in this trial. The second attribute for the trial node is children. It just means that the tree node for this particular trial node. That's pretty standard for the trial class actually. So let's look at the main class, or rather the main function. First, we're gonna initialize the length of the word on line 7 as n. Then we're gonna start at the root. Then for each forbidden word inside the forbidden list, we're just gonna add everything inside the trial node. So that's what we do for each character, and you just add them inside the trial node. If it doesn't exist, then we just create a new trial node in this trial. That's pretty standard, and we just keep going to the children. And finally, on line 16, we're gonna mark this current node as true for the isAn attribute to notify that this node, if we hit this node, it means that we have hit the forbidden word, which is W in this case. Now, as I mentioned earlier, we're gonna have to keep track of the rightmost fail start, because if we want to include the current index I, what is the rightmost that it failed? That's so basically what is the closest next start we can pick if we want to include the index I. Then for each character in this word, we're gonna try to go 10 steps for each index of the word. So in here, we just do some basic checking. If this 10 steps go outside of the window, then we just break, or we just keep track of the actual index of the character. If it doesn't hit anything in the trial, we should break as well, because there is no forbidden word for us to hit after this node. Otherwise, we're just gonna keep going to the trial node, and if this node is actually isAn is true, it means that we have hit a forbidden word. So in that case, we're gonna update our rightmost fail start, because there's actually a word failing at this particular K position. So what is the fail start? The fail start is just I. So just indicate that if we want to include index K, then we shouldn't go anything before or on I. That's basically what it is. Then we're going to do our sliding window technique, going from having a left and right pointer, and also keep track of the answer. Initialize as 0. In the worst case, nothing gonna match, so in the worst case, gonna be 0. Then we're gonna iterate the right pointer. The right pointer is gonna increment 1 by 1. And the L pointer is gonna jump according to the value of the rightmost fail start. So if the rightmost fail start R is not equal to -1, it means that if we want to include R, there is something failing at R that has a start. So as we mentioned, we're gonna take this fail start plus 1. So this is the earliest place that we can go. And after jumping L to this rightmost fail start, then L is in the valid position, or rather, L and R, this range, is a valid range that doesn't contain any, forbidden string. And eventually, we can just return the answer. Let's try to submit this code. Okay, accepted.